So we'll go to the next concept of diffraction. Okay. So write down the next heading as diffraction. So diffraction is basically a single slit interference. So what is it? It's a single slit interference. Okay. So I'll show you how does a single slit experiment look like. So see, let's see, there is a laser light being passed through a single slit. Means you have a single opening. When you switch off the light, generally what do you expect? For example, let's say there is a scenario like this. Light is being passed like this through an opening, and you have a screen here. What do you generally expect? So you expect the light to go and fall like this, and so you expect the light to go and fall like this, and you expect only that area to be bright. So which area? You will expect this area to be bright. But in reality, what happens is after the light strikes an obstacle, it starts bending like this in such a way that this part itself will be bright. Right? So why is this happening? It is because light exhibits a phenomenon of getting bent. Because light is a wave, and waves have the property of getting bent at an obstacle. Okay. So the phenomenon where there is bending of light taking place when it strikes an obstacle. Bending of light when it strikes an obstacle is called diffraction. So there is a difference between diffraction and refraction. In refraction, what happens? It moves from one medium to another, but here it is happening within the same medium. So when it encounters an obstacle, light starts bending is what is called as diffraction. Now, if you see, if you look at the experimental part, it looks something like this. When the light goes and falls on the screen, though it has passed through the single slit, What do we expect? We expect the complete part to be bright. But if you observe, there is only a certain region which is bright, and see, this is how it looks like actually. Is it not an output that we expect out of interference when two slits are there? Right, but here it is happening with the help of one slit itself. And an important point that we need to note here is, we can see that the central spot is bright and you have a dark on either side of it. Again, you have bright, again, you have dark, bright. So it's a continuous pattern of this sort. So in this case, our job is only to give an explanation of why this is actually occurring. Okay. So if you observe the screen, you have a bright spot, you have dark, again you have a bright spot, again you have a dark. It keeps on going like this. Am I right? Are you able to understand what I'm trying to say? Right. Now, if you see among all the bright spots, the central bright spot is the brightest one. After that, you see the intensity keeps decreasing. Okay. So the central bright spot is called as central maxima or central max. Generally, they call it as central maxima. Okay. What is a central maxima? How is it formed? Now, if you see, if I call this as the slit, okay, and if I take the width of the slit to be A, and light is going and falling from the ends of the slit. So actually what will happen is, if there is a wavefront passing like this, after it strikes the obstacle, it starts passing in this way. So it starts getting split into wavefronts and it keeps moving. When it moves, you can think of drawing multiple rays for it. Can I? Can I think of drawing multiple rays? Out of these multiple rays, for the explanation of how central maxima is formed, I'll be taking a ray which is going from the top and hitting the screen and bottom and hitting the screen in such a way that it exactly travels in such a way that S1O is equal to S2O. When this happens, what is the path difference between both? 0. So when the path difference is 0, what kind of an interference takes place? Is it constructive or restrictive? It is constructive. Delta X is equal to n lambda. You will not get n is equal to 0. If you take, you substitute it here, delta X will be 0. So when the path difference between two rays which are striking a point is 0, then it undergoes constructive interference. So S2O minus S1O will be equal to 0. So because of this constructive interference only, because of the constructive interference, what can you say? There is a bright spot exactly formed at the center. And what is the name of it? Central maxima. So please make a note of it. Clear? Shall I proceed? Now, if you look at the first, so write down the heading as first minimum. So when you want to give an explanation for how the first minima is formed, so first minima is formed between the central bright spot's upper end and the first bright spot's bottom end, which is B1. So this region is dark. Am I right? I'm saying dark spot is formed. So if this is the width of bright spot, then you will have width of dark spot. Then again you will have bright spot and you will have dark spot. So it keeps going in the alternate way. Now what I'm trying to say here is the first dark spot, the first minima. See, first minima is grammatically wrong. Minima. Okay, you take up and down. Okay, so first minima. What you can say is, so it is between the upper end of the first bright spot and lower end of the second bright spot. That is upper end of the central maxima and lower end of the first bright spot. Is it right? Now, if let's say this is the place where the dark spot is appearing. Now, what I will do is, though the width of the slit is A, I'll assume that it is broken into two small parts. So that this is A by 2 and this is A by 2. So that between the top point and the first slit, let me call this point as S1. And between the middle point and the bottom part, let me call this point as S2. So that I am considering one ray from S1 and one ray from S2, so that they are meeting at point B to produce a dark fringe. Is that point clear? So unlike the previous case, can I say that these two rays are traveling different distances? So what should happen is S2P minus S1P should be AC path difference. But the path difference between two consecutive rays is supposed to be exactly lambda by 2 for that spot to have destructive interference. So I'm using the word again. Path difference between two successive or consecutive rays. Path difference between two successive rays should be how much? Exactly lambda by 2. Path difference between any two random rays can be 2n plus 1 lambda by 2. But successive artha, it should only be lambda by 2. So, ipo parunga. So, here I have S1, S2. S1 is going and striking the screen at point P. S2 is going and striking the screen at point P. So if this is S1, this is S2. If I take this to be theta, this will also be approximately theta only. Because the width of the slit is very, very small. The diagram looks big. Okay. Since I assumed that it is broken into two parts, observe. So this is A by 2. If I say this is X units below the top point, okay, and I'll say this is X units, sorry, and this is also X units below the top point. Then how much is this distance? So A by 2 minus X. And how much is this distance? It is already X. So if I take a point here and point here, how much will this distance be? A by 2 minus X plus X. With Maxima, cancel, it will be A by 2. So the distance between the two slits that you considered, S1 and S2, will be A by 2. I repeat it again, listen. This is the top point, this is the bottom point. I'll explain it again, listen. So this is how the slit is. Okay. So from the top point till S1, it is considered, that is X. So how much is this distance? Okay. And from the midpoint, this distance is also x. Then how much is this distance? A by 2 minus x. But no, you're considering it symmetric. No. From the top, at a distance x, you're considering 2 points. See, from the top of first slit, it is S1. From the central part, again, at a distance x, you're considering a symmetric point. You're considering 2 symmetric points. So A by 2 minus x plus x will get cancelled. You're getting A by 2. Okay. Now observe. So if this is A by 2, you drop a perpendicular here. Okay. So if this is theta, this will be 90 minus theta, then this will be theta. So that is A by 2 sine theta. So the path difference A by 2 sine theta should be equal to lambda by 2. Correct? So 2 and 2 will get cancelled, which implies A sine theta is equal to lambda by A. So which implies sine theta is equal to lambda by A. Generally, the value of theta will be very small, that it is approximated to theta is equal to lambda by A. Generally, the width of the slit itself should be very, very small. Only then you can observe this diffraction pattern. Which one you want to do? Path difference between two successive rays should be lambda by 2. I call them as successive because I considered them symmetric. So A sin theta is equal to lambda is a condition for the first minima to be formed. So this is the condition for first minima. This can either be in the upward direction or downward direction. Okay. Is it clear? Those who are online, is it clear?
Yes, sir.
Okay. Shall I proceed?
Yes, sir.
So next we will see bright spot is over, dark spot is over. Again you have bright. No? This bright spot is called as first secondary maximum. Because you have a central maximum already. So it's called as first. You cannot call it as first maxima because first is already formed at central part. So you need to give a name. First secondary maxima. So for the first secondary maxima, again listen. Let's say this is the width of the slit, which is the width of the slit, which is A. Okay. Now what I'm doing is I'm assuming that it is broken into 3 parts. So so this is A by 3, this is A by 3 and A by 3. So for central maxima, how many parts was it broken into? 1 part. First minima, 2 parts, even number of parts. First secondary maxima, 3 parts, odd number of parts. So what I will do is, if I consider a point S1 in between the first 2 dots, I'll use another color C. Symmetric to this, I will consider another point between the second and the third. Symmetric to this, I will consider the third point here. So that one ray goes and hits here. Second, third, let this point be P dash. So if I take this as S1, S2 and S3. Now tell me one thing. The ray going from S1, S2 and S3, are they all supposed to undergo constructive interference? Because what are we trying? I am trying to give an explanation for first secondary maximum. Is that right? So if the rays are going from S1, S2 and S3, they go and fall on the screen and they give us. But here the question is that bright fringe brighter than the central maximum? No. Suppose, theoretically you're saying that rays from S1, S2 and S3, everything has undergone constructive interference, then you should have had a brighter spot than the central maximum, which is not happening. So what will happen is, the rays from the consecutive rays from S1, S2 and S3, out of which the consecutive two rays are supposed to undergo destructive interference. What will happen? The rays from S1 and S2 will fall on the screen destructively. So what will they produce? Dark spot. But the ray from S3 will add to the dark spot some amount of light. So rays from S1 and S2 are to undergo any two rays. If S1, S2 successive rays, S1P dash to S2P dash, what should be the path difference? Otherwise, S1, S3 lambda confused. Another, I took it as successive. Okay. Then S2P dash minus S1P dash should be equal to lambda by 2. But what is S2P dash minus S1P dash? That is A by 3. That is A by 3. So A by 3, not A by 3, I'm sorry. It is not A by 3. So again, if you take this ray to be theta 1, this ray to be theta 2, and this ray to be theta 3. So if you draw a perpendicular from here, how much will this distance be? It will be A by 3 into sine theta 1. Is it right? So A by 3 into sine theta 1 A by 3 into sine theta 1 is equal to lambda by 2, which implies sine theta 1 will be equal to 3 lambda by 2a, which implies theta 1 is equal to 3 lambda by 2a. Actually speaking, you are getting this, no, a sine theta 1 is equal to 3 lambda by 2. This is the condition for the first secondary maximum. Clear? Just to give an explanation. So first we started with 1, then 2, then 3. Next we'll go to 4. So 4 இருக்கும்போது என்ன form of dark? ஏன்னா even number இருக்குல்ல. 2 will undergo destructive. The other 2 will also undergo destructive. Other 2 will also undergo destructive. அப்பதான் dark வரும். So when I break it into 4 parts, not this one, I'm talking. Even it will be dark. When you take even number of parts, then only 2 rays. So 2 will undergo destructive. So the whole concept of diffraction will not explain with the concept of constructive use panna mattom. You always explain it only with destructive. And what is the logic? For destructive interference, the path difference between the successive rays are supposed to be lambda by 2. That's the logic. Only for destructive. Constructive, it should be lambda. The path difference between two successive rays should be lambda for it to have constructive difference. But that's what I'm saying. We don't use that concept at all. Is it clear? So for the secondary maxima, how many parts are we supposed to take it in? Secondary minima. Secondary minima, we will break it into 4 parts. Upper width of each slit will be a by 4. Width of each slit will be a by 4. A by 4, A by 4, A by 4, and A by 4. Okay. If I again raise further, it is going and hitting the screen at point B. Okay. Then what you will do is, if you call this as theta 2, for example, then this path length will be A by 4 sine theta 2. So A by 4 sine theta 2 is supposed to be equal to lambda by 2, because that is a path difference between successive rays. So cancel this and this, which implies A sine theta 2 is equal to 2 lambda for destructive interference. For the secondary maximum. So if you keep doing it, secondary minima. What is the condition for first minima? A sine theta will be equal to lambda. Second minima, A sine theta 2 lambda. Third, you will break it into how many parts? 6 parts. A sine theta will be equal to 3 lambda. So what will be the last part? A sine theta is equal to n lambda. If you observe, is it not exactly looking like the reverse of constructive interference? It is looking like that because you have the product of A and sine theta. So A sine theta is equal to n lambda is a condition for nth minimum. This is the condition for nth minimum. For bright spot, delta x is 0. For first secondary maxima, first secondary maxima, what will you do? Another A sine theta is equal to 3 lambda by 2. 3 lambda by 2 or the lambda by 2. Correct. 3 lambda by 2. Correct. Second secondary maximum. You will have 5 lambda by 2. Like this, if you have nth secondary maximum, what will you have? A sine theta will be equal to 2n plus 1 into lambda by 2. So it will be an odd multiple of lambda by 2. Where you are supposed to. Practical but theoretically it doesn't. Theoretically it doesn't. Two n plus 1 minus 1. ஏன்னா ஃபர்ஸ்ட்டுக்கே வந்து 3 லாம்டா வருது இல்லை 3 எப்போ வரும் 2n + 1 வந்தால் தானே 3 வரும். அதனால அங்க 2n - 1 இருக்கு. அதுக்காக தான் நான் when I explained it, I told you should be careful with suffix yn இல்ல yn + 1. அந்த மாதிரி ப்ராப்ளம்ஸ் நான் பார்த்துருக்கேன். I've seen mistakes. சார் ஒரு வருஷம் ஒரு மாதிரி பண்றாரு. அப்ப புரிஞ்சுதா உனக்கு? இப்ப புரிஞ்சுதா? அது சடனா வந்து மாத்திடுவாங்க. ஏன்னா சொல்யூஷன் புக்ல அப்படி இருக்குன்னு வச்சுக்கோங்க. அப்படி பண்ணிட்டு போயிடுவாங்க. அப்படி பண்ணக்கூடாது. எப்பவுமே ஒரு ஸ்டாண்டர்டைஸ் மெத்தட். அதுதான் பிரச்சனை. அதனால தான் எக்ஸ்பிளைன் போகுது. இதுக்கு இல்லை, இது கொண்டுதான் இருக்கு. ஏன்னா இது ஸ்டார்டிங் வித் 3 இல்லை. புரியுதா? Guys, those who are online, are you able to understand?
Yes, sir.
Is it clear?
Yes, sir.
Did anyone speak? இருக்காங்களா?
Yes, sir.
Good, good. Last 2 weeks. Next week அப்படி இருக்கு. ஸ்கூல்ல கிளாஸ். சானக்கு. That's why I'm tired. Train also won't work. 5 hours na edutha. Continuous 5 hours. 5 hours I can actually take. 8 hours kuda edutha. But I need break. Continuous approach. Okay. So this is all about diffraction. Okay, listen. If this is the screen, you have a bright fringe. Okay. So what is the top part of the bright fringe? It is the starting point of the dark fringe. So if I take it like this, if I take this angle to be theta and this angle to be theta, how much will the value of theta be here? It will be lambda by a. Here also it will be lambda by a. Accepted? Yeah. Because when theta is equal to lambda by a, when the light is getting bent at an angle of lambda by a, it goes and hits the screen to form the first minima. It is forming the first minima here. இங்க கூட first minima. நான் இது புரியுது இந்த லாஜிக். அப்ப what is the total angle here? So total angle because for the first minima a sin theta is lambda. When the value of theta is very small, theta is lambda by a. புரியுதா? So total angle subtended by the bright fringe எவ்வளோ? By the central bright fringe எவ்வளோ? 2 theta வா? அது வந்து எவ்வளோ? 2 times lambda by a. Let me call this as equation number 1. Okay. அதே மாதிரி if I talk about the nth minima being formed here and n plus 1th minima being formed here, from the central spot, what would this angle be? Theta n will be equal to lambda, n lambda by a. first minima na lambda da, second na 2 lambda. என்னன்னா அப்ப n lambda by a வா? அப்ப இங்க எவ்வளவு இருக்கும் angle? n plus 1 lambda by a. அப்ப அது ரெண்டுத்துக்கும் நடுவுல what will be the angle? n plus 1 lambda by a minus n lambda by a. That will give you lambda by a. So angle subtended by any bright fringe other than the central maxima is how much? Lambda by a. So angle subtended by bright fringes 2 times lambda by a. Angle subtended by any other bright fringes lambda by a. That is why if you see the fringe width of central maxima is equal to twice the fringe width of any other maxima. So this is an often used formula. What is that a logic? Done. So this is how it works. So this is all about diffraction, and this is the end of the chapter. Polarization is not there. Okay. This is the end of wave optics. And yes, I need to upload the video related to reflection and diffraction. And either I have to do some problems based on this. So problems, maybe I'll do it in the next class. So yeah. So what I will do is, you almost, with this chapter, we have almost completed the major chapters. That's easy. Modern physics, dual nature is all. You can put it as 2 classes. 1 hour class na, 2 classes enough. So 8 more classes maximum, means less than a month. We get 3 classes a week, right? So 8 classes na evlo varum? Less than 3 weeks will be completing the syllabus. Okay. So after that, you will have continuous tests and revision with the number. So start preparing, and 5th, 6th, 7th, that week alone, you will have tests. All 5th, 6th, 7th September. That is not the coming week. The week next to it, you will be having tests. Test. No, for whatever topics have been completed, you will be having this. I'll send you the schedule. Okay, so I'm just informing you in advance, start preparing. Mostly I'll be conducting from this volume only, ray optics and wave optics. Most of one. I'll do that and be prepared. So yeah. Diffraction problem, maybe we'll do it next class. And I don't have the collection ready. I'll prepare it in the next class. Apart from this, any other doubts that you have? Monica, clear? Those are online, any doubt?
No, sir.
Okay. And you guys can leave. You had some doubts, no? Get it there. You guys can leave. Monica, get the doubt clear. Get the doubt clear. Sure. I don't think so. Last week when we